Welcome back to Geometry Chapter 8, Section 5 in this book. If you don't have this book, you can still learn the ideas, and the idea is proving triangles are similar. Not congruent, similar. So like we have a big one and a little one. If they're similar, then their angles are going to be the same, and their sides are going to be in the same proportion. Alright? So there's, well, just like how we proved triangles were congruent, by side, all of those things, you have similar things to prove they're similar. So this is one of them, and it is also called side. But it's not the same, because it's not that if the lengths are equal, it's if the lengths are proportional. If all three lengths are proportional, then the triangles are similar. So here we have two to check, a big one and a little one. And if you want to see a good drawing, look in the book, not mine. Alright, but we're going to pretend, use your pretending, that they look the same. Alright, and now we're just going to check. 10 is to 5, as 8 is to 4, as 12 is to 6. Yes, because each of those, it goes into it 2 times. 5 goes into 10 2 times, 4 goes into 8 2 times, 6 goes into 12 2 times. So if we made those a proportional statement, it could be, you could write it 2 to 1, or you could write it 2 to 1, or you could write it 1 to 2, or you could write it 1 to 2. So depending on which one you put on top and which one you put on bottom. Alright, so another one is side angle side, and it said that if 2 sides are proportional, and the angle between them is the same, then they are similar. So 10 is to 5 as 8 is to 4, check, and 30 is between them. It's the included angle. So yes, these are proportional. Check. Okay, so now we're going to play, are they similar? Like Rhett and Link, Will it taco? Are they similar? Alright, so we have these 3 triangles turned different ways, but all basically the same triangle-y shape. So we're going to see if they're similar. I call this one A, that one B, and that one C. Saves time. Okay, and the longest side for each of them is blue. The shortest side for each of them is red, and the in-between side for each of them is green. Okay, so first I'm going to compare A and B. So I'm going to compare their shortest side, putting the big triangle on top for each one. So 6 is to 4, as 9 is to 6, as 12 is to 8. And if I reduce them, they all made 3 halves, so yes, those are similar. So now I'm going to check A to C. And the first one I did was the smallest ones, and it was 6 to 6, which is 1. I don't even have to do the rest, because I know the answer is nope. Absolutely nope. Okay? Because, and I know if C is not similar to A, it's not similar to B, because A and B are similar to each other. Okay? Now, they have a proof in your book, it was where you're supposed to prove that the big triangle is similar to the little triangle with what's given. That this length is 4, that one's 5, that one's 12, and that one's 15. And if you want to read the paragraph proof, read it in your book. I'm just going to do the logic of it, okay? So what I did was, first of all, I added together 4 plus 12 to get 16, so I have the length of the whole side here. And 5 plus 15 is 20, so I have the length of the whole side. I don't want to compare sections, I want to compare the whole side to the whole side here. You got to compare apples to apples, oranges to oranges. I like fruit. Okay, so now I'm going to make my ratio. The big triangle on this side is 16, and the big triangle on this side is 20. And the little triangle is 4 on this side and 5 on this side, and they both make 4/5. You could, I could have compared the long side of the triangle to the short, like I could do this side to itself. So it would have been 16 is to 4, and it would be 5. Well, 20. I'm putting the big one on top. 20 is to 5. 16 divided by 4 is 4, 5 into 20 is 4. So that works too. You can compare it either way. You can compare sides of the big triangle, or you can compare the big triangle to the little triangle, You just have to make sure you're being consistent through the problem. So the two sides are similar. We don't know about the third side, but so we can't use side, side, side. Two sides are similar, but we can prove it because angle S equals angle S by, there's the mirror, the reflexive property, then we know that we can prove that these two triangles similar by side, angle, side. Da-da! Okay, in your book, they also did a problem where they used a tracing contraption where you trace over a picture and it blows it up. I remember those being in my high school when I went to the high school in the 80s. Even then they were out of technology. It was just old technology that was hanging around in the drawing room. But anyway, y'all should take a look at that. It works on this property of similar triangles. And they also do a thing in the book where there's a guy and he wants to figure out how tall a rock climbing wall is by putting a mirror on the floor and getting his image. Nobody does that. There's an easy way to do it. You're going to learn in just a few chapters using trig. And you're going to do it the real way, the trig way. We're not even going to bother looking that way because nobody does it. It's just like a hypothetical that's not used. All right? So come back next time and we'll talk more about similar things. Math is great.